Okay, so it's not actually determining the limits. We're supposed to determine whether these statements over here are true and false for this function. And I'm sorry, it's kind of blurry. I took it with my phone, and I'm not good with the phone, I guess. I thought I had it. So sorry about that, but this is asking for the limit as x approaches -1, and then this plus in the top right corner in like the superscript position means from the right. So find x equals -1. It's right here. When they say x approaches -1 from the right, that means tell us what the y value is as x gets closer and closer to -1 coming from the right side of the function. And so the y value here is like it's maybe 3/4, and it's 7/8. It's closer and closer. The y values are getting infinitely close to 1. So this is a true statement. The y values are getting infinitely close to 1. The limit is equal to 1, we would say, as x approaches -1 from the right. The limit as x approaches 2 of f of x. So this one, actually, let me make sure I got this written down right. Yeah, okay, so I don't think this has really come up in the book too much yet, but this is saying the limit as x approaches 2, and it doesn't have a symbol, a plus or minus symbol like this one did, right? So that means you need to consider what the y values are as x gets closer to 2 both from the left and the right side. So here's x equals 2, right? As you get really close to 2 coming from the left, this is an open circle. So you can get infinitely close, but you never reach y equals 1. Well, actually, no, sorry, I shouldn't say it. You can get infinitely close, but never reach x equals 2. The y values stay constant. So the limit as x approaches 2 from the left, we'd say is 1, because those are the y values. As you get closer and closer, it never changes, keeps staying 1. That's from the left. The limit as x approaches 2 coming from the right, they get closer and closer, but they never hit, x equals 2, we never actually hit that dot, so we never jump up to this part of the piecewise function. The y values are constantly 1. So the limit from the left is 1. The limit from the right, it's 1. So the limit as x approaches 2 of f of x should be 1, not 2. So this is a false statement. Okay, and that's the calculus part. This circle has no width, right? It's not got no radius, it's got no size. It's infinitely small. So you can get infinitely close to 2. You can approach this limit. You can get infinitely close to 2 without actually getting to x equals 2. Okay? You can get infinitely close to x equals 2 without actually hitting it. The y values you're getting, though, as you get infinitely close, are 1, not 2. So this is not a true statement. Limit as x approaches 2 of f of x does not exist. Now, that's also not true. This is false. The limit does exist. Okay? Even though this point jumps up here, it's a removable discontinuity, this limit does exist, and the limit is 1 we just found. So this would be a true statement. To say that the limit does not exist is false. Okay? So that's the real calculus part. You're getting really close to 2. The y values are 1. If you want exactly -2, if you want to plug in exactly 2, the function spits out this dot up here. But anything else, f of 1.99999, that gives you approximately 1, right? You get infinitely close to it. And then this is repeating. In the same way that 1/3 is equal to 0.3 repeating. It's a straight equals, right? That's what limit notation is. As you get infinitely close, 1.9 repeating, the y values are 1. Okay? Okay, so a lot to say because this is like the first calculus stuff, right? Part D, the limit as x approaches 1. This says from the left. So find x equals 1 right here. Now see what the y values are as you get closer and closer to 1 from the left. So the y values are at 1.5 right now. The y values are up here. The y values get infinitely close to 2. So this is a true statement. But f of 2 would be 1. Okay, this is the non-calculus part. Oh, wait, sorry. Whoa. F of 1 would be 1 is what I meant to say. If you plug in exactly 1 into this function, the solid dot says your y value is 1. But if you take the limit as you get infinitely close to 1 coming from the left, the y values are getting infinitely close to 2 up here. Okay. The limit as x approaches 1 from the right. So we're picking x values that get closer and closer and seeing what happens to the y values. The y values are getting infinitely close to 1 here. Okay. So that is a true statement. The limit as x approaches 1 does not exist. This is also true. This limit doesn't exist because look, the limit from the left was 2. The limit as x approaches 1 from the left side is 2. The limit as x approaches 1 from the right side is 1. Those aren't the same, so we have to say that the limit doesn't exist. The two limits have to agree with each other. In part G, the limit as x approaches 0 from the right, so here's 0. We want to think about the y values as x gets closer to 0 coming from the right. The y values are getting infinitely close to 0. Okay, so this limit is 0. And let's see if it's equivalent to the limit as x approaches 0 from the left. So thinking about the y values, got 0.5, 1/2. We're getting infinitely close to 0 from the right. So those are equal to each other, so this is a true statement. This says the limit exists for all points between -1 and 1, not including the endpoints because of the parentheses. So here's -1, here's 1. The limit does exist for all these points because we don't have a removable discontinuity like this or a jump discontinuity like this. There are, every limit we take for any point in between those two, it does exist. They agree, right? This is the only potentially scary point, but we just evaluate that. The limit as x approaches 0 from the right and from the left, they were the same, so that limit as x approaches 0, it does exist because those two-sided limits, the left and the right side, they both agree. So this is true. Limit as x approaches c of fx exists at every c. So it's just basically saying you can find the limit for every x value between 1 and 3. So it means it starts here when x is infinitely close but never touching 1 because of the parentheses, and 3. This is also true. This is a true statement because you can take the limit of any x value. Limit as x approaches 1.5 and you're not going to have a problem. The limit from the left and the right are going to be the same. We just evaluated the limit as x approaches 2. The limit from the left and the right, they both existed. The limit was 1, we saw up in this part, right? So the limit does exist there. It exists for everything up to x equals 1, x equals 3, and everything in between. So this is another true statement.